Okay, hello everyone. This is a next video related to your shortest route path algorithm. Coming to this, the problems which I gave you for your mid questions. This is the second problem in that. So here I'm not going to write any information related to that. I just solved it and I'll explain you how to solve this particular problem. How did I solve it? Okay, you can just go through it. Okay. So here actually coming to this is a path. This is the graph which has been given to you, and we need to find the shortest path from. As I already told you, the shortest route path algorithm is nothing but discrete routing algorithm, and how it works. It's nothing but from the source node we need to find a shortest distance to every other node which is present in this particular graph. Means let us consider node A as the source node. So from here we need to find the shortest path to B, I, J, H, G, F, E. So remember in the graph, whatever I gave you, I did not represent D here, so don't get confused here. So after C I have given E. Okay, I did not give D. So in the exam also, if the same pattern has been provided to you, you people had to write in the same way. Okay, don't get confused and after C you just write it up E. Don't do that kind of mistakes. So without going further discussions, let's go deep into it, solving of the problem. So in the very first step, I told you what we need to do. We need to represent a pair in each and every node what we have in this. So we are representing that as infinite comma dash. You can observe it 0 comma minus, and this is the source node. So we have represented with the arrow, and remaining all other nodes we are represented with infinite comma minus, infinite minus, infinite minus. Okay, if there are any mistakes on this, please ignore. There is a mistake, I'll tell you where it is. You can just modify it, okay, when you are solving the problem. Okay, so step 1 is completed. Now since source node is A, from here what are the nodes that are connected to source node A? We can see B and I. So we are going to update B and I. So that is the value is 4 comma. Okay, so infinite will be replaced with 4, and it is via which node? A. So we are writing here 4 comma A, and next this node will be updated node I. That will be nothing but we can replace with 6. Okay, so this value is 8. So 8 comma A. So you can observe here. So how many nodes right now we do have is B and I. Okay, so B and I, among these two we need to find the next source node. So B and I are in the queue, so which one is shortest? We'll compare it. 4 and 8, definitely 4 is shortest. We are considering B as this next source node. So this is what the arrow that is represented here. Now from B, what are the paths we do have? We can go through it. So from B we have two different paths, or we can say that two nodes are connected to B. One is C, one is I. Okay, so I is already been updated with 8 comma A. So there is a possibility we may get less. Let's see how much. So from B to I, what is the distance we have is 11. So if we want to go to node I via from A, from A, okay, via B, what is the total cost it is going to take place is 11 plus 4 is 15. But already for node I we got the shortest path, that is 8, because 15 is greater than 8. So definitely we are not going to replace this, we'll keep as it is, we are not going to update it. And since we have here infinite for node C, we are going to update. So 8 plus 4 is 12 comma what is this? B, node B. So 12 comma B, that is what we did here. So you can observe here. So we have updated this value 12 comma B and 8 comma A. We did not change this. Now how many are present in the queue right now? So in the queue we have two nodes right now. Okay, one is C. I was already existing here, and the next node what we have is C. Now among these two, which one is shortest, you have to find out. So here what is the value we got here is 12, and what is the value we have is 8. Which one is shortest? I. Node I is having the shortest distance, so we'll consider this as the next node. Okay, so in the queue, when we are considering this as a source node, we are removing it from the queue. So what is left in the queue is C. Remember, keep in mind that C is already in the queue. Okay, we did not visit C right now, we are visiting I. So this particular node C is in the queue. Now this will make it as a node near here it is, where it is, yeah, here I. So we made it as a root node. From I we have four different paths, 1 2 3 4, but we will not be replacing anything for this. From A to A or something like that, we are not going to replace, because we are trying to find the shortest distance from source node A to all other nodes. So you cannot find a source node A to distance, I mean the shortest path from source node A to source node A. So we are not going to consider this particular line. Now if you consider I to B, Okay, if you consider this, so what is the shortest path we got is 8. So 8 plus 11, how much you're getting is 19. So if you want to go to B from A via I, the cost it is going to incur is 11 plus 8 is 19. But already to reach B we got the shortest distance is 4, so we are not going to replace this. And then we'll see the next two paths we have J. So J is represented infinite comma, so we can update this. So 7 plus 8 is 15, so 15 comma I we can replace here, and here 8 plus 1 is 9, so 9 comma A. So this is what we are doing here, 9 comma I. Okay, 9 comma I, 15 comma I we have dated. And I already told you, now we need to determine what is the next source node. And I already told you that in the queue C is existing. Apart from C we got two more new nodes, that is J and H, right? So among these three, which one is the shortest you need to find. So C is having 12, J is having 15, H is having 9, so obviously 9 is shortest. So we'll consider this as the next node and we'll remove it from the queue. And in the queue, remember, now two nodes are existing, C and J are in the queue. Okay, so this is for your understanding. I'm just saying how to solve this particular problem. So next consideration has been done for which particular node is node H, and from here you can see there are two paths going, actually three paths, H to I, H to G and H to J. So since we are coming from I only, so we are not going to consider this particular node, so we'll consider only this node and this particular node. Now if you look at here from H to J, what is the distance we have is 6, and what is the value we got here is 9. So 9 plus 6 is how much? 15. Now if you observe here, if you're going via I, you're getting the same distance, that is same cost or same distance, 15. So definitely then you will not be replacing it, since I told you that first come first serve. Already 15 you got it, so here also 15. If it is less than 15, then we need to update this particular value, but since it is 15 both sides, so you can keep the initial one as it is. So we'll remove this, we'll not consider this. Well, next one is this is infinite comma minus, so we'll update it. So 9 plus 2 is 11, so we'll represent here 11 comma H. Okay, so this is what we did, 11 comma H. And in the queue, as I told you, what are the values we do have among these three? What is the values we have right now? C and J are in the already in the queue, and after that now we have added G, so G is also in the queue. So again in the queue we have three values, three nodes, C, J and G. Among these three, which one is shortest we need to find. So 12, 15, and what is the value of G? We got 11. Which one is shortest? 12, 15 and 11. Which one is shortest is 11. So this we are going to consider as the next. So again remember that in the queue, C and J. Okay, so J, did we consider J? No, we did not consider it. Okay, so C and J are in the queue and we are considered G, so that is removed. So already two are there. Now from G we are having how many paths connected, how many nodes are connected? 1, 2, 3 and 4. Since we got it from H, we'll remove this. Now we'll find the distance for this. From via G, if you are going to see what is the cost it is going to take place is 11 plus 4 is 15. But already to go to C, though now you're going from G to C, but it is the source, it is from A to C via G you're going. So what is the path, what is the cost you're getting? 4 plus 11 is 15. But whereas coming to C here, you can see that if you are going from A to C via B, you're getting the shortest path 12, so we are not going to update that. Next comes something called E. So E is not updated, we will update it, so it will be something like 14, right? 14 plus 11, 4 plus 1, 5, so 25 comma G. Okay, it's 25 comma G, and same way this one will be updating it. This will be something like 11 plus 10 is 21, 21 comma G. Okay, so this is the next diagram where you can see this. It's represented here. Yeah, 21. Yeah, this is the mistake what I did here. This part you can see, this is the mistake I did. Actually it is 21 comma G, but actually I have written 21 comma H. You can overcome that, you can solve that. Okay, you can just modify it when you're solving the problem. Now in the queue, what are the values we have? C is left, J is left, right? This is done. Now again what happened, two more values came into the queue, that is E and F. So among C, J, E and F, which one is the shortest you have to consider. So 12, 15, 25, 21, obviously 12 is shortest, so this is the node what we are going to make it as a source node. From C we are going to find it out now, the values. is there whether there will be any updations or not. Okay, so actually there will be an updation, because from C to what are the from C, what are the links we have? C to B we have, C to J, C to G, C to E. Now if you observe here, C to B, actually we are coming via B, right, to C. So definitely we are not going to consider this. We'll simply remove this particular line. We are not going to consider, we'll remove it. After next, what we have, C to J, the distance is 2. Now if you consider this particular distance, 12 plus 2 is how much? 14. So means what is the value initially for to reach J we have is 15 via I. Now if you are going from source node A to J via C, you are getting the shortest distance. 12 plus 2 is 14. So yes, we can replace this particular value. So what is the value we are going to update is 14 comma C. So you can see here 14 comma C is the value we have updated. Okay, this value is updated. Next we have C to G. Now if you look at here, to C to means if you are going via H to G, you are getting the shortest distance as 11. Now from C to G, if you are going, 12 plus 4 is how much? 16. But the shortest distance already we got 11, so we are not going to replace that. Same way if you observe here, yeah, this one also I think it will be replaced here, as you can see in this particular step, that from C to E, if you observe what is the distance total taking, 12 plus 7 is 19. But if you are going via G, the distance is 25. Okay, this is from source node A. So 25 and this is 19. Which one is shortest? Obviously 19. So we will update same like J, we will be updating this particular node, and you can see in the next diagram here how it is replaced. So you can see 19 comma C. If you can see here, initially it is 15 comma I, now it is replaced with 14 comma C. It is 25 comma G, and here it is 19 comma C. It has been updated. Okay, now after completing this C as a source node, what are the within the queue, how many nodes existing here right now? 1, J, G, E and F. Okay, sorry, G is completed, J, E and F, these three are present in the queue. So which one we can select right now? So 21, 19, 14, which one is shortest? Obviously J is shortest, we are going to consider that. And when you are considering 14 comma J, there will not be any kind of upgradations, as we already received the shortest path. You can go through it, like for example from J, since we are coming from C, we will remove this path. There are two paths here, 7 and 6. So J to I, the distance 7, so 7 plus 14 is 21, but the shortest distance what we received is 8 via A, so we are not going to replace that. Same way 14 plus 6 is 20, but the shortest distance what we received to H is 9 via I, so we are not going to replace. So 9J is completed. Now we are left in the queue with only two different nodes, node E and node F. Which one is shortest? That is node E is shortest, because it is having 19. So we'll make this as a source node. From here we need to see there are two different paths we have, 1 to G and F. Since G already received the shortest path, you can observe here 19 plus 14 will be much more bigger value than 11, so we are not going to replace that. Same way 19 plus 9 is 28, right? So 28 is much more bigger than 21, so we are not going to replace it. Finally this node, from this node you will not be getting anything. Finally this, so this is the final outcome of your for. So if I ask you what is the shortest distance from source node A to F, you can say that the distance is 21. Now if I ask you what is the path, same way like the previously I explained you, backtrack it. Like for example G, okay, where is G? H, where is H? H came from I got it from A. So what is the shortest distance path is? Shortest path is A, I, H, G and then E. Okay, you're getting it? How to find it? How to find it is simple. If I ask you what is the shortest distance from A to F, okay, then you can say it is 21. But if I ask you the path from A to F, then you can represent with, you can just backtrack it from F. So this is G, right? So G, then G got it from H, so this is H, H got it from I got it from, so A, I, H, G and F is the shortest path from A to F. Same way if I ask you what is the shortest path from A to C, okay, so you can say if you just backtrack it, C got it from B, so B got it from, so A, B, C is the shortest path. And what is the shortest distance we have from A to C is 12. Okay, thank you, we'll provide you the next video. Thank you.